Good afternoon, everyone. Today we will be entering a hands-on session for machine learning in healthcare. For the hands-on session, we will be considering a simple dataset from Kaggle for heart attack analysis and prediction. Let's go to the link where the dataset is present. Here, CSV file is there. One CSV file is there called as heart.csv, which has different attributes such as age, sex, EXANG, CA, CP, TRT-BPS, COL, FBS, REST ECG, thalage and target. What are they? For this, some demographic data has been considered, like age is the age of the patient, sex is the sex of the patient, that means whether female or male. EXANG is actually denoting the exercise induced angina. If the value of the attribute is 1, that means it is having angina, and if the value of the attribute is 0, then that means it is no angina over there. And CA is actually the number of major vessels, which actually ranges from 0 to 3. Now comes the fifth attribute, which is the chest pain type, CP. Chest pain type, for that one is if the value is 1, then it is typical angina. If the value is 2, atypical angina. If the value is 3, non-anginal pain, and if the value is 4, asymptomatic it is. Now coming to the next one, that is the TRT-BPS, that is actually resting blood pressure in millimeter Hg. And cholesterol part, it is looking as cholesterol in milligram per dl fetched via BMI sensor. And FBS is the fasting blood sugar, and if it is 1, if it is the it is showing the value 1, then that means the fasting blood sugar is greater than 120 mg per dl, and if it is showing 0, that means it is less than or equal to 120 mg per dl. Now the next attribute is REST ECG, that is the resting electrocardiographic results. If the value is 0, then that means it is normal. If the value is 1, then having ST wave abnormality, that means T wave inversions and or of ST elevation or depression of greater than 0.05 millivolt. And if the value is 2, that means it is showing probable or definite left ventricular hypertrophy by SS criteria. The next attribute is thalage, which is actually denoting the maximum heart rate achieved. And the final attribute, which is the class level, actually it is the target. That means if it is actually 0, then that means the less chance of heart attack, and if the value is 1, then that means more chance of heart attack. So these are the attributes, and from these attributes we have to classify that heart attack chance, less chance or more chance. So based on these attributes we have to predict the less chance or more chance. Now how can I run a code for that? I'll be showing an example of simplest SVM, that is the support vector machine, already discussed by ma'am. So for that I have considered Google Collaboratory, for which you have to go to colab.research.google.com, and after going to this link, it is actually called Google Colab in short, and for that you have to go to that link, and then you have to sign in to your Google account, whatever the Gmail account you have to sign in. In my case it was actually already the passwords saved, so I didn't have to provide the password over here. But in your case, if you are using Google Colab for the first time, so you have to sign in with your username and password, and then you can see various types of codes. So here I'll be showing the heart.inv file, as I have already prepared that. So hard.ipynb I have already opened, and for that actually I am going to use the SVM classifier. Already the functions are defined by the Python compiler. So import numpy as nm. The numpy module has to be imported. Then matplotlib, and from the matplotlib package the pyplot has to be imported, and from the pandas we can call the pandas package as pd, so import pandas as pd. Now we have to actually import the train test split function from the model selection part of sklearn. So we have to import that, and we have to import the svm also, so that we can use various functions of it. So from the sklearn, svm also has been imported. Now the data, coming to the data import part. So importing the data sets need actually loading of that particular dataset into my Google Drive. Whatever the Gmail account I have signed in with, in that Google Drive, in that particular mail ID's Google Drive, you have to store the hard.csv. That means the CSV file, actually the dataset. So you have to store there, and then you have to mount that Google Drive using this content drive, my drive, then hard.csv. That means it is the path basically from which the hard.csv is going to be fetched from my Google Drive, and pd.read.csv from the pandas package. The read underscore csv is the function which is going to fetch the csv file, and it is going to name the csv file whatever is inside there, the csv, that is going to be called as data for the rest of the part. Next I have to mention what are the x values in my code and what are the y values. That means based on the x values the y will be predicted. So x is data, that means from the data file the age attribute, sex attribute, cp, trtbps, chol, fbs, stcg, thalach, exeng, oldpeak, slp, caa and thal. These attributes have to be fetched, and for these the values actually have to be fetched. So inside the x we have to store the values of age, sex, cp, and the rest of the x values, that means the independent attributes name, and then dot values, which actually fetches the values of these attributes. So x is storing that, and y is storing the output. There was a column called as output, so output dot values, that means whatever the target variable is storing, those will be considered as y. And next we have to split the training and test split the entire dataset into training and testing, and for that we have considered the test size as 0.25. That means the train size will be 0.75. That means the entire dataset is divided into two parts. 75% of the dataset is considered as the training set, and 25% of the dataset is considered as the testing dataset. And for that train test split, this function has been used. Then x and y have been supplied as the first and the second arguments, then the test size, and then random state can be 0 and 1, 0 or 1 actually I can say. So x train, x test, y train and y test, these things will be determined from the train test split output. And then actually I can delete this cell. Now I have to give some values of the hyperparameters of SVM model. So if the hyperparameters of SVM are kernel, gamma, c value, the most basic three parameters have been considered over here. One is the kernel, another one is gamma, and c value. So if I consider the linear kernel, then I have named the model as linear underscore MDL. MDL stands for model. So as the kernel linear kernel has been considered over here, so I have named the model as linear underscore MDL. And then from the SVM package I have to use the SVC function, and inside that function I have to supply few arguments where the kernel will be mentioned, whatever the kernel I am going to use. It can be actually different combinations, the values can be different. For one it is linear, some other kernels are there also as sigmoid, for some other value it is RBF, that is the radial basis function. So different kernels are there. If you go through some literature about SVM, that means the working mechanism of SVM, you will be seeing different parameters of it. What is the meaning of kernel? What does it do? What do we do by deferring the values of kernel? So different topics are there, you can go through. So if the kernel has been chosen as linear, then gamma has been chosen as scale, and the value of C has been chosen initially as 1, and probability is true. And then I have to I have to call the function fit, and under that two values have to be passed, two arguments have to be passed. One is the x train and one is the y train, so that with the training set, that means with the 75% of the entire data set, the x values and the y value will fit the model. So dot fit, that means the fit function, and under that function two arguments are being passed, x train and y train. And then if the model has been trained in this line, then ypred you can name it otherwise also, no problem with that. I have just named it ypred, and for it is actually used for the prediction purpose. That means after my model has been trained, I have to predict the value of a particular um, test case. So for that, linear MDL, that means the model name, then the predict function, and then X test. So from the testing part, that means from the 25% of my data set, that is the testing data set, the X values are only passed inside the predict function, and for that I have to find out the Y prediction, that means the value of Y. The value of Y means 0 or 1. 0 means more, less chance of heart attack, and 1 is more chance of heart attack. So Y pred will be showing 0 or 1. Okay, and whatever the Y pred will be uh, showing, that means whatever the Y pred will be returning, after that I have to find out the accuracy of the training stage. So accuracy linear train, I have named it that way, and then my model name, and then score. This score function actually takes two values inside it, one is the x train and one is the y train. So the training parts values, variables actually, x values, that means the independent values, and y value, that means that is the dependent value, which depends on the x values. So in the training portion, if I want to see the accuracy, then print accuracy linear kernel, and then I can print the value of accuracy linear train. Whatever this score function has returned for this linear model, that will be stored in this accuracy linear train, and that will be printed over there. So accuracy linear kernel in my case is 0.853333. And if I want to find out the accuracy of test case, so accuracy linear test, and then linear model score, x test and y test. So here the accuracy linear test is showing 0.8, as the score function returned has returned 0.8 in the accuracy linear test variable. So the value of accuracy linear test is 0.8 in this case, and it has been printed by this line only. So this is it. And if I want to print the confusion matrix for the same, I have to import classification report and confusion matrix from the sklearn.matrix package, and there I have to take another variable called as linear pred, you can name it otherwise also, and then from the linear model I have to use the predict function for x test. Whatever the x test will be returning, that will be the prediction case. And for that, if I want to print the classification report for y test and linear pred, then that looks like that. And if I want to plot ROC curve for my experiment, for that a function has been defined over here, plot ROC CUR, that means curve, plot ROC curve, and two types of variables have been passed over there. One is the f percentage, that is the false percentage, and two the TPER. So false positive cases and true positive cases have been passed over there, and I have defined the graph color as orange, and I have labeled that using ROC, as this is the ROC curve in my case. So ROC, and then another line has been plotted for which the color is dark blue, line style is dashed line. So this type of line style has been shown over there, and it is starting from 0 1 point, it is going up to this point. So this is the PLT plot function, and in x axis I want to label it as false positive rate. So PLT dot x label is false positive rate, and in the y axis I want to show the label as true positive rate. So here I have passed y label as true positive rate, and then the plot title, that means the graph title, if I want to supply something as the graph title, then that will be passed as title functions argument, and then legend if I want to put, then plt dot legend, and then finally the plt show part. So like this the ROC curve can also be drawn, and if I want to find out the AUC value, that means area under the ROC curve, so that can also be done using AUC equal to matrix dot ROC AUC score. That is the function for finding out the AUC score from ROC curve. So that is the function being called from matrix package, and here the two arguments are y test and probes. So the final value of AUC has been printed over there as 0.8314 in my case. You can try to improve the model also by changing the parameter values, and here one confusion matrix has been shown over here, over this figure also. For that you have to call confusion matrix function, and you have to pass two arguments. One is the y test, and that means the value of predicted y, and linear pred, that was the model name. So linear pred, and then you can plot the figure with these things. If you have any confusion, you can ask me in these things, and this way the confusion matrix can be plotted. And now after sometimes if you want to change the values of your parameters of SVM, so in that case you can change that using this type of thing. I have actually named the model as RBF11, as I have supplied the kernel as RBF, that is the radial basis function, and I have supplied the gamma value as 1, and I have supplied the C value as 1. So I have named it RBF underscore 1 underscore 1. As I will be changing the value of gamma from 1 to 0.1, then I will be naming it RBF underscore 0.1 underscore 1 if the value remains same of C. So kernel RBF I have named it this way, and I have called the SVC function from the SVM module like the previous case also, and here decision function set is OVO. You can give any value, whatever the possible values are, and then probability equal to true, and then fit x trend y trend like the previous case. So in that case also accuracy can be calculated from this score. X10 y10 will be the arguments of the score function, just like the previous case, and training accuracy and testing accuracy can be printed like this. And for this particular case, we are seeing that the training accuracy has been reduced and the testing accuracy also has been reduced. So in the previous case it was something 80 something, and it is showing now 0.54, that means 54.666 percentage it is showing as the accuracy. So the accuracy has reduced in this case, so we don't have to consider this one. I have to change the parameter values manually, or I can use some automatic hypertunic packages of Python. By that, automatically the best case, that means the best combination of hyperparameter values can be considered. So thank you. If you have any confusion, you can ask me.